Good morning, everyone. This is a really interesting venue for a conference. I learned this morning that Dave Chappelle played here, so that's a tough act to follow. So I will be talking about conversational AI, and our goal here is to understand how we can get computers to interact with us naturally. And there are many of my colleagues actually here in the audience who've contributed to this work, so if you're interested in any of this stuff, go find them or find me, and happy to tell you more about what we are doing. Let me get this thing turned on. Those are my coordinates if people want to get in touch later on that. So we've all seen things like this, quotes like this. So we talk about how we are moving beyond the age of touch. It's now the age of voice. We've seen Alexa, we've seen other voice-based agents out there. And if you look at where AI is going behind this, right, the goal is to enable us to interact with the machines naturally. For decades, we've been typing to our computers. Since about 2007, after the iPhone was launched, we've been touching and swiping and pinching and zooming with our computers. The technologies were invented before that, but that's when it really became mass market. And then since 2015, there's been another change with the launch of Echo. And again, the technologies have been here for a while, but that's when people started speaking with their computers. Our goal is very simple. This has been my goal for years, and as a researcher, I'd like machines to learn how to communicate with us. If I want to talk with you, I'm not typing at you, I'm not touching and pinching and zooming, I'm just talking. And you're listening and talking back. Why can't we do that with our devices? Not just computers, but all our devices, cars, thermostats, fridges, TVs. So that's the eventual goal of this whole movement. So I wanted to introduce Alexa. Actually, I'll have Alexa. I brought Alexa with me. I'll have her introduce herself. Introduce herself.
I'm Alexa, and I'm designed around your voice. I can provide information, music, news, weather, and more.
So folks familiar with Alexa? People have Echo or other devices, a few are not. So Alexa is actually the cloud-based agent that lives inside this device and many others like it. And I'll talk about how she works and what she does. She's sort of everywhere. There's one Alexa. And so the magic here, part of the magic here is that every time anyone interacts with Alexa, Alexa learns a little bit and gets smarter for all of us. And we'll talk about how that works as well. Alexa was initially launched inside a family of devices made by Amazon. So that was the original device, the Echo. The Tap is the mobile version, which is what I'm holding. There are these little Alexa dots, which are they're the under $50 version. There's tablets, there's TV, and so forth. It's the same Alexa in all of them. Alexa is now also in your Amazon mobile app. The magic that made Alexa work, where the revolution really began, was in Farfield voice recognition. I have Farfield turned off, otherwise Alexa will go off every time she hears a name in this talk. But you can have Alexa sitting in the corner of your room. You can have friends over. There's music playing. There's noise, maybe there's something going off in your kitchen, and you say, Alexa, play some music for me, or what's the weather like outside, or how late is the beer store open, because you're running out of beer for your party. Alexa will hear you, cut through all the noise, hear you across the room, and respond to you. So what makes that happen is this sort of far-field voice recognition. There's a microphone array, and our engineers and scientists do a lot of work in enabling these devices to hear you naturally. So that's, again, part of that natural interaction revolution. We don't have to pull out phones and swipe away at apps and sort of find these gadgets to interact with and learn different user interfaces. You just talk, and she's there and she's listening. Alexa now comes in many other devices. You can get Alexa in a watch. That's actually a cooking device. There's Raspberry Pi. A lot of people like to hack with that. Alexa is coming to your Ford. That's a video communicator. More of a sort of a kid's communicator toy, and so forth. Lots of smart home devices are now Alexa enabled. You can turn on your lights, lock your doors, turn on your rain sprinklers and those kinds of things. So what do you do with Alexa? So there's a lot of use of entertainment. You can play music. You can play music from Amazon. You can play music from Spotify, Pandora, TuneIn, listen to the news. We're very open about how you want to use Alexa. We're not wedded to getting you only into an Amazon product. If you want to buy Alexa in a third-party product and use her to play music from Spotify, we're just fine with that. Because at the end of the day, the goal is to enable you to interact with the technologies you like in a natural way. A lot of household uses, timers, to-do lists, shopping, alarms, and so forth. Informational question and answer, facts, weather, traffic, local information. I mentioned smart home. There, in fact, now this slide is out of date already, 15,000 or so skills developed by third parties. So Alexa will get pizza for you, play games like Jeopardy, check your bank, get your cappuccino ready. These are some of the popular things you can get. Order flowers for your mom on Mother's Day, get an Uber, check flights you can check your health status, lock your doors, and so forth. Lots and lots of users, tens of thousands of these things now. And so there's all the sort of the reviews you read, what people are saying about Alexa. I won't go over all of this. I, as a scientist, am much more interested in what people are doing with Alexa, as opposed to saying about it. So there's a very large kind of smart home population, almost a third of the users now. Of course, music, things like timers, shopping carts, and so forth, listening to news. People have Alexa in their bedroom, play music at night, set an alarm for them. Alexa's in bathrooms, where people will listen to the news while they're getting ready or play music in the shower. Most people have Alexas in sort of the kitchen and living room areas. A lot of people have multiple Alexas, and one of the interesting things is that there are always more than one user in most cases for Alexa. So 82% of Alexas have more than one user interacting with them in your house, because she's not your device, she's just in the house. Your kids, your family, your friends, everyone interacts with them. So it's actually the first computer for a long time that's not a personal computer, which is very interesting. So the way that we make this available to everyone is through two interfaces, or we call them services. The Alexa Skills Kit on the left is an open API that allows you to add skills to Alexa. And this is what, for example, Domino's uses to add pizza delivery capabilities to Alexa. And again, what's interesting is as soon as Domino's adds that, every Alexa in the world now can order pizza. It's instantly available to everyone. So if you have any kind of application, business service, game, anything for which you would normally build a web interface or a phone interface, if you would like people to interact with through voice, you can add an Alexa interface to it very easily. It takes a day. Takes a weekend. I have a friend who's middle schooler has written Alexa skills. It's very, very easy to write this. You don't have to go take a course for 6 months to learn how to do this. On the other side, you have the Alexa voice service. Those are the APIs that allow you to put Alexa in another device. So if you have a watch or a Fitbit type tracker or some other gadget, and you would like people to speak to that gadget and not have to have an echo to speak to that gadget, you can put Alexa inside that gadget, and that's done through the Alexa voice service. So we are seeing a lot of applications. Our goal is to have Alexa everywhere. Audios, cars, security systems, really any technology. The goal is, let's not have you learn interfaces to technologies and figure out dials and buttons. Just talk to these things. And at CES this year, there were a number of companies that announced Alexa devices. Again, cars, smart fridge. This is interesting. You can talk to your fridge and ask about what's in your fridge and when you need to reorder stuff. Lots of speaker type things. Dish Network just launched. You can control your television, no more fiddling with VCRs, and so forth. In fact, the slide is now getting overpopulated with Alexa type devices. So this is where the AI comes in. The opportunity now is, as AI people, we have a platform which allows us to connect to millions of people using Alexa, tens of thousands of skills on Alexa, capabilities on Alexa, in dozens of different devices all around their house, their cars, and everywhere, right? huge opportunity for AI and also a huge challenge of AI. So simple challenge is you have a device like this, you've got your home set up, and you say, Alexa, which Alexa are you talking to? There's a bunch of them, right? And so we are working on technology, we call it echo spatial perception. You see marketing people at work here, ESP, where when you say Alexa, Alexa figures out which Alexa you meant and automatically directs your voice to that particular endpoint. Harder problem is, imagine again, you have all of these different use cases and you start talking to Alexa. We now have to understand what the user is saying and do the appropriate thing. That's where the AI comes in, right? So AI in this case, it's all about language. We know language is hard, and I'll go through some of these problems with AI. We have to understand free-form speech in a noisy environment. We have to understand what the user meant, and we have to understand what the user was intending to say when they said what they said, because people don't always say what they mean. When you add conversation, when Alexa has to speak back to you, the problem gets even harder. And we'll talk about some of these problems. So let me illustrate these problems by some examples. So the speech recognition, we call this the cocktail party problem. Again, imagine you have a party at home with a bunch of folks talking, and someone over here says Alexa. You've got to cut through the noise, pick up that voice, zero in, and understand that person with very high accuracy. Now we go on, and this person is cut off a little bit here. This person says, Alexa, play some Pink. We have to understand what that means. Now notice the person didn't say play, the person said play Pink. What they meant was play music by a band that's P exclamation mark NK. We have to make that translation. So here's some examples which are harder. Anyone know the answer to this? Alexa. Oh, are we off?
Sorry, your tap lost its...
Okay, we're off Wi-Fi. I'll just tell you what Alexa would say. So you would say, Alexa, you can say this to Alexa. So this is still an issue. We do need to be on Wi-Fi. Who was the president of the US when Barack Obama was a teenager? There are actually 4 answers. Again, what's interesting here is the understanding part. There isn't a Wikipedia page you can look up with these answers in there ready to be spoken out. You have to understand what it meant, figure out what the time period is, go find the information, assemble that, and speak it back in a very short, natural English sentence. And all of that has to happen in under a second, which it would if we had Wi-Fi. Intent recognition, right? Alexa, is it hot outside? Right? The answer to this question isn't no. The answer to this question is, depends on what you meant when you said that. Usually what you mean with this question is, what's the weather like? And so then the answer might be, it's 54 degrees in San Francisco, right? So we have to interpret what the user said. Alexa, wake me up in the morning means Alexa set an alarm. And there are myriads of ways people say the same thing, and we have to sort of map that and understand the true meaning of what was said. Now we get to conversation, now we get to responding to this, right? Alexa, I want to see a movie. I understand what that means, but what's my goal in saying that? Why are you telling me this, right? So Alexa now has to figure out what's an appropriate response. I mean, do you want movie recommendations? Do you want to see what's playing nearby? Do you want to play Netflix? What are you asking for? And so Alexa may have to converse back with you to try to understand what you want and give you what you're looking for. A lot of context modeling. Who is Barack Obama? Barack Obama is whatever. Who is his wife? You now have to know that his means Barack. When was she born? When was he born? So you have to keep the context of the conversation. Alexa would do this quite well. And know who you're referring to as you go through a multi-step conversation like this. Looks easy for us, super easy for humans. 5-year-olds can do this. Very hard for AI. Here's another context problem. So in the previous example, it was about the context of this conversation, right? People know what is 42? I wish Alexa was working, she would tell you, right? This is what Alexa says, 42 is the answer to life, the universe, and everything. The trick is knowing what the question is. This works because we have a shared context, not part of this conversation, but part of the world around us that allows us to understand this question and say the right thing. So modeling context is super hard, and super critical when you start talking about natural conversation. Response generation. Alexa, should I watch the new Wonder Woman movie? What's an appropriate response to that? Question, right? Yes, someone said yes. Okay. So let me now switch gears a little bit and show you how all of this works. So those are the problems we solve. How does Alexa work? So when you say Alexa, we send your request up to the cloud where Alexa is running. And in the cloud, we understand what you mean. In this, let's say you said, is it hot outside? You're asking about the weather. We send you to what we call the weather skill. There are tens of thousands of skills, many built by Amazon, many built by other people, each of which are sort of experts in a domain of interest. So again, Domino's Pizza skill is expert in ordering pizza. Starbucks is expert in coffee. Weather is expert in weather, etc. So you think of these as sort of little experts. They get your request. They decide what to do, they produce a response, and the response gets sent back to you in voice, and if appropriate, through a visual means. So it would come in your app. If you've seen the new Echo Show, it might come on your screen. If you're doing this on a tablet or television, you might see something on your television screen. Right, so under the hood, the processing that's happening, let's say I said, Alexa, is it hot outside? I'm getting an audio signal. The audio signal goes through what we call signal processing, and we get what's called a beamformed signal. So again, in a noisy room, I need to zero in on exactly where the voice is coming from and focus attention there. That's called beamforming. And so we have technology for beamforming that will allow the device to detect the wake word, the word Alexa, on the device. We don't want to send your audio to the cloud for privacy reasons until we are dead sure you're talking to us. So we do all of the wake word detection on the cloud. If you're sure you said the word Alexa, now we get that signal. We send your audio up to the cloud, and we do speech recognition that turns the signal into words. We then do intent recognition or natural language understanding that turns those words into meaning, like getting the weather. And then we pass it to an AI that says, okay, now we know exactly what the user meant. What should we do with this? Maybe you look up the weather. You may have to infer something with the weather where. You meant the location where you're at. If you had just referred to some, if I said, when was she born? When was who born? You just referred to Michelle Obama. So we have to do all of that reasoning. We form an answer, and we give it back to you. So dig into these a little more detail. I'll go through this fast because this is not really a technical talk. So for beamforming, we take all of these microphones, we combine the signal, and then there's on the device, there is technology to cancel echo, right? So we can, again, the device is playing music maybe, there's other noise, so we have to sort of cancel all of that out. And so Alexa is very good at picking up the word Alexa inside of that very noisy environment. Okay. So a lot of the common theme behind a lot of the technologies you see here is data-driven machine learning. We use a range of machine learning techniques, including the ones you're familiar with and some that you may not be. We've learned that there isn't sort of one magic bullet. It really takes a cluster of different approaches to be hybridized together to do this problem really, really well in a natural environment, people's homes, average people's homes. So it's a lot of probabilistic modeling, and as with most machine learning models, you sort of train a model based on a lot of training data where you have the ground truth, and then the models are used to decode input when it's being used. We have a lot of technology. This was a paper we published, or our scientists do publish papers if you want to go find how some of this stuff works. This was published recently. This is an interesting problem. Again, back to the noisy environment problem. If you said Alexa, what we do is from the word Alexa that you spoke, we pick that up through beamforming. We look at features of your voice pattern that help us identify who's speaking. So when you say play some Pink and stop, and someone next to you continues to talk about something else, Alexa doesn't think you're still talking because the voice that we heard initially has stopped talking. And so we can pick up, so when to endpoint your conversation. Speech recognition, this is again, I won't go through this in a lot of detail. We take the audio signal, we extract audio acoustic features. We also have a language model because it helps to know the context of what you might be talking about in addition to looking at the features of your words. And we combined the acoustic model along with the hybrid model into a decoder, and then at runtime we extract features from your words to figure out the words that you might be speaking. There's also a lot of AI involved in speech synthesis. So if you want to say, let's say you have a skill, the skill says, I want to respond with, she has $20 in her pocket. We have to now say that out in English in a very natural intonation. And so we normalize the words, we turn that into phonemes, we generate the waveforms, and then we speak it out. Let's see if okay, so it looks like let's see if this will work. Okay, the audio is not connected. So then I'll skip this example as well. There's a lot of AI technology that goes into optimizing the way the speech patterns work. And then if I had audio, maybe I can just play directly off my laptop and have you listen to it.
Over a lunch of Diet Cokes and lobster salad one balmy fall day in Boston, Joseph Martin, the genius, white-haired, former dean of Harvard Medical School, told me how many hours of pain education Harvard med students get during 4 years of medical school.
Sounds okay, little bit stilted. And if you look at this one now, after the AI gets to work on this.
Over a lunch of Diet Cokes and lobster salad one balmy fall day in Boston, Joseph Martin, the genial, white-haired, former dean of Harvard Medical School, told me how many hours of pain education Harvard med students get during 4 years of medical school.
Very, very subtle. Makes all the difference in the customer experience. And when you have Alexa sitting in your house and talking with you, a lot of times during the day, this sort of adds up, and you start to think of Alexa as being sort of this natural, human-like voice, even though, I mean, we're not trying to pretend we're human, but it sounds natural. It doesn't grate on you after a while. Oh.
Lunch of Diet Coke.
Okay, she wants to tell you. So, okay, so let me get to the last couple of slides. So if you want to use Alexa yourself, there's sort of 3 ways to get engaged in this. One is to use the skills kit to build skills and capabilities for Alexa. As I mentioned, it's very simple, and if you can Google for it, or if you ask me, I'll tell you how to find this. But this is really meant for people who have software applications that you would like people to be able to talk with. There's the Alexa voice service, which is meant for hardware developers. So if you have a device and you don't want people to have to learn how to operate the device through an app interface or directly through knobs on the device, you would like people just to talk to it. As long as the device has a microphone and a speaker, we can enable that for Alexa, and we have a team that will work with you to make that happen very effectively. And then I think I saw on the list some entrepreneurs here. If you have an idea for a startup or working on a startup, we have the Alexa Fund, and then we actually now have also the Alexa, I think it's called the Launchpad, if I remember right, which is sort of an incubator for startups that are doing interesting things with voice. And we're open to you using other kinds of voice platforms. Doesn't have to be Alexa-based. We're just trying to sort of enhance the scope of things that people do with voice in the technology arena. And so you can apply to that. We do everything from very early stage seed funding all the way to tens of millions of dollars Series C round when you're ready to scale. And we'll do any depending on the stage of your company. And again, if you're interested, get in touch with me. I can tell you how to apply to these things. We also are working with universities. We recently launched the Lexer Prize, and we have a couple of folks here, including myself and then some in the audience, working on this. This is a competition for university students to build a conversational capability for Alexa that will allow Alexa to speak with you coherently and engagingly for 20 minutes about something that's popular that day, something in the news, sports, politics, entertainment, Wonder Woman movies, anything like that. Hard problem, there's $1 million prize if you can do a 20-minute conversation and keep the user engaged. It's not about Turing tests. You're not trying to fool people into thinking you're human, and the judges aren't trying to trick you into your bot into revealing itself. We're just talking. The question is, can you speak engagingly and coherently? These are the universities that are competing in this competition. And I wish Alexa was alive. I would demo one to you. But we have now opened this up to everybody. So if you have an Alexa device, you can say, Alexa, let's chat, and get to speak with one of these, we call them social bots, at random, and give them some feedback. This very, very early days. They're just getting started. They're not great yet. But every time you speak to some of these, you give them more data and help them improve. And we've already seen in the last 3 or 4 weeks, the social bots have started to improve pretty much day over day as people interact with them. So I'll just end with sort of what our secret sauce is. The real secret sauce behind Alexa is the human capital that goes into it. They have a really, really stellar team. I've been there 1 year, and I'm completely blown away with the quality of the people there. And so on that note, we are hiring. We hire all the roles from scientists, engineers, product managers, marketing, user interface designers, user researchers, hardware people. I don't know if I missed anyone. So if you're interested, again, all our jobs are posted there. We have a booth outside with a person who can help you sort of connect into the Alexa community if you're interested in even just kind of exploring what might be out there. So come talk to us. And I will end with that. That's my LinkedIn if you want to connect back with me and follow up later. And I will leave some time for questions. Thank you. Go ahead.
So obviously, what's next for Alexa? Obviously, we want to make it ubiquitous. We want to bring it to as many people as possible. But where are you looking to go next? Is there going to be some level of personalization with how you interact with Alexa? What are you thinking currently?
So all of the above. At Amazon, we are very driven by what customers, users of Alexa tell us. And you may tell us just by asking us questions like this. You might tell us by writing back to us. Or you might be telling us just through your actions. We get a lot of data coming in from millions of people using Alexa every day. And we look for patterns in what people are trying to do with Alexa. And we prioritize the things that we think will give users what they need. So all of the things that you mentioned and many more are on the roadmap. We prioritize them based on where we think the big win is. The goal eventually, our sort of dream here is to sort of get rid of, that old-fashioned interfaces to everything. Now, there's always room for those. We're not going to replace them. We still use a keyboard, even though we have touch phones. When you're making this PowerPoint, I'm not going to use my touch phone for that. So there's uses for keyboards, there's uses for touch devices. But for 80% of the use cases for regular people in their everyday lives, let's just talk. So we want to have Alexa everywhere, in billions of endpoints around the world. Part of the reason that we're working with other companies, like the ones you saw, to embed Alexa in other devices is that I think we realize that we cannot build billions of devices and serve the whole world ourselves. So if you notice on that list, there are some competitors on the list. Bose is making a smart speaker with Alexa that will compete with Echo. We're just fine with that. If you prefer Bose to Echo, get Bose. We're not trying to, because we're not going to solve everyone's speaker problems or other problems. We just want you to have Alexa. So that's what really driving our vision here. Yeah. Okay, right behind you.
I think I got the microphone.
Okay. Then you got to go.
Yeah. So one of the challenges of voice interfaces is how do you engage users to start the conversation? And on that note, you have announced that you're going to start having push notifications on Alexa sometime soon. So I want to understand, what's your take on that, and how is that going to operate? Of course, you don't want the speaker to be talking to you all the time when you just walk by.
Yeah.
So what's the role of push notifications on a voice interface?
Yeah, great question. So there's a lot of research being done right now on sort of proactive agents, right? So Alexa being proactive in initiating a conversation with you as opposed to waiting for you to initiate a conversation with her. There are some cases where that might be natural if you have a message. So Alexa now allows you to make phone calls and leave messages just through voice. And with the Echo Show, video calls as well. if someone left you a voice message, you might want Alexa to tell you when you walked in the door that, hey, you have a message, particularly if it's a message from someone important. In other cases, you may or may not want that, so we would like to give you the choice on which notifications you enable and under what conditions. But behind the scenes, we do a lot of research with real users in real settings on how people respond to notifications, what the notification should be, under what conditions they should be given. And there's also associated with that, if you talk about, let's say, the Alexa Let's Chat feature, how chatty do you want Alexa to be? If you're in a hurry getting out to work in the morning and you just want the daily briefing and you're out the door because your traffic is building up, you don't want Alexa sitting and chatting with you about Wonder Woman movies, right? At home when you're chilling out after work, maybe. So there's a lot of contextual work as well. So we're doing a lot of work with personalization, contextualization, and so forth, really driving this from customer experience. Actually, a lady sitting right in front of you is one of our user experience experts and has done a lot of the design for the kinds of voice interfaces and experiences that you get on Alexa. So yeah, those are all on the roadmap. If there are particular things you would like to see, let us know and we will work on them.
Hi.
Gentlemen, the mic has the power here.
Good talk and an excellent device, but I have a bit more of a challenging question. You gave the example of, say, you want a Domino's pizza or something from Starbucks. I think that a lot of the time that you'd use it to communicate are exactly for these sorts of, just one-off quick things. And the minimal, you need basically no programming to be able to do to add your business information to Google Maps. You needed even less to be able to put it in the yellow pages. But if you're like a local coffee shop or a local pizza place, how do you expect Alexa and other things where you need to talk to them to become simple enough that it doesn't become an aggregation of only a handful of really huge chains dominating all the ways that you can interact with it?
Right. So we very recently announced a tool set for the mom and pop coffee shop type people to add skills to Alexa. The way it works is very simple. What you do is you've got a capability you want to expose to the world, like ordering coffee. You write down a list of some of the typical sentences you would like Alexa to be able to handle for you. You say, here are the kinds of things people might say to my coffee shop. I want a coffee, I want with milk, I want whatever it is. So you write a few of these down. And that is the program. The rest of that happens automatically. Our machine learning engines go to work. We train a system. We extrapolate from the sentences you gave to find others that users may say that have the same meaning, bringing the natural language understanding into it. And we will train up the machine learning systems to recognize and give you the signal that someone wants coffee, and will deliver it to your back end in a form that you want, right? So there are also now, what we just announced was a drag and drop tools that let you build simple dialogues. So you can not just get what the user said, you can ask them a question back. And so you might say that, you might ask, do you want whole milk or skim? And you can sort of say, if the user says, I want coffee, and they haven't specified the milk, you can sort of build a branch and write those things down. Very simple. Again, as I mentioned, middle schoolers are doing this. Very simple tools to enable everybody to do this. We're certainly not focused on just the dominant companies becoming more dominant. Go ahead.
So my question is related to the Amazon Web Service. Recently they launched a new natural language understanding managed service called Lex. I want to know, is Alexa using this behind the scene?
Great question. So the question, if people didn't hear it, was AWS, the Amazon Web Services, announced a new service called Lex, which is a natural language processing system. Along with Lex, there's also Poly, the natural language generation system, and there's recognition and so forth. Lex is based on Alexa technology. So it's not, and so behind the scenes, what we did was Alexa's natural language engines are so good, and we got a lot of people saying, could we use this in some other application that isn't Alexa based? Can we use it in our own application outside of Alexa? So we pulled that out and made that available to folks like you who want to use it. So you get the same power of the same technology, but you can, without the rest of Alexa coming with it.
I see. Yeah, that's a great question because we are evaluating some, platforms for our new, new initiatives, and I see this Alexa as kind of a good fit, but I want to know because Alexa is a pure consumer, world. So that's actually so that for example, in terms of NLP, right? So intent, classification, recognition, entity recognition, things like that, need training data. So these data sets mostly come from, pure, consumer worlds. Does it actually provide some flexibility that so we can, as our own training data set, for our, business purpose? Do you know? I'm not sure it's the right person to
Yeah, so you should look at Lex for that. And if you catch me afterwards, I can
sure.
put you in touch with
thank you.
people. Okay. So there's one gentleman behind you as well, and one up here.
Thank you. Just to get an idea about the investment required, if you take an application, like you said, finding the status of the account in the bank, like in Mint application, and you want to build a voice interface, what do you have to invest many months, many years using the Alexa?
What do you say the last part again?
What should you invest if you want to build a voice interface to a Mint-like application that you want to know all kinds of things about the account?
Right, so there are several applications that are doing that now. Again, we call them skills. Fidelity Bank has one, several other banks have announced capability to check the status of your bank balance, whether a check is cleared and other things through the voice interface. Typically, what you would do as an application designer for that is put that behind a password so any random person can check your bank balance when they come to your house.
Oh, you should find out by the voice if this is the right person, no?
That's a great idea. I will pass that back to our engineers.
So how much should you plan for? If I want to build such an interface to an application that is doing just that, what should I plan for? Many years, many months?
Well, you can build that interface now using the skills kit, and you would then, if you wanted to put it behind a password, you would then put it behind a password. Right.
Thanks.
Would there be a standalone Alexa app that doesn't have to use the additional hardware? So it uses the smartphone hardware to...
Right, so the Huawei phone is Alexa enabled. Alexa is part of the phone, and actually I could have used this for my demos. If you open the Amazon app and press on the microphone, Alexa, are you there?
Showing items matching
So,
microphone.
Alexa, are you there?
Yes, I'm here. I
So-
listen when you press the mic button.
So Alexa is in your phone already and works, just on that. And you can actually, I could have done the Let's Chat demo on this as well. So yeah, there's a goal to again put Alexa everywhere. The device, the actual gadget, isn't the big goal here. The goal is to have Alexa, the AI, be ubiquitous, and we'll put her into every form factor we can.
So will the smartphone work without the gadget itself?
I'm sorry?
Will the smartphone function without the gadget attached to it?
Yeah, so the smartphone has Alexa in it, independent of any other gadgets that you might have. So if you have a phone and don't have an Echo device, you still can use Alexa.
Okay, thanks.
Excuse me. Thank you. I have a follow-up question regarding the security. So I guess obviously the voice pattern is probably not safe enough to identify somebody for a use case for checking the bank account, for example. So what are some of the ways you are thinking of that you can use to identify somebody in a more safe way?
Yeah, so I can't comment on what we're doing with that particular problem, in part because I'm not allowed to comment on roadmap, and in part I just don't know. It's a huge company with lots of teams doing lots of things. But typically, if you look at what people do in the voice recognition world and look at the research out there, there's a combination of cues from speech signals and other things that can be used to train machine learning networks and other kinds of AI systems to recognize tone of voice and other things. So that would be the way to do it if you wanted to try to solve the problem. Actually, if you want to solve the problem, come work with us and we'll help us solve it. But it's an interesting question. If again, it's part of the Amazon culture here that if there are enough people who ask for that feature, we will prioritize it. Right, and we read, it's interesting to me, been there for a year now, that all of us, from the most senior people to the most junior people, read customer feedback. If you type something into your app and give us feedback, we read it, we get it. And then all of that sort of factors into our roadmap planning. Okay, so are someone tracking time?
Yes, time should be
1 more minute. Okay, so let's take maybe 1 or 2 more, depending on how fast we speak.
Quick question, since the goal is ultimately conversational and you've done an amazing job of exposing NLU, are there any plans to expose any kind of NLG functionality to, beyond just speech generation, but to actually support the generation of natural language back?
Oh, that's a great question. So that's a good distinction between the generation of the speech part of it to make it sound natural, and then before that, the NLG to figure out what the word should be in the first place. So that's something that we are currently have not exposed. The speech part has been exposed through the AWS service called Poly. But that's an interesting problem. That's actually another hard problem. It's in general, that's an unsolved problem as well in AI. It's funny, we think nowadays we have AI that drives cars and does geological prospecting and plays Go and all kinds of things. The hardest AI problem is conversation. It's still unsolved, and we think of it as not a hard problem because again, our 5-year-olds can do it, but that's a super hard problem. And there's a lot more to be done out in the scientific community before we can build products that will do it. Okay. Well, thank you all, and I'm here if you guys want to talk some more.